Okay, now we're going to talk about the horizontal stretches and compressions. And if you'll remember, when we did the vertical ones, this a value was on the outside of the function. For horizontal ones, the a value is on the inside. Now you can kind of make some comparisons with your vertical and horizontal shifts also. Remember, with the horizontal shift, then we were adding or subtracting inside with x. For the vertical ones, we were doing something outside of the function. So you might be able to make those connections there also. Okay, this says that we're going to, in order to achieve this shift, we're going to multiply each x coordinate by an a number, a value. So if that a value happens to be between 0 and 1, this is going to stretch the graph horizontally. And if the a value is greater than 1, it's going to compress the graph horizontally. Okay, let's look to see what that is going to look like. That'll help us, I think, the best. Okay, so I'm going to start off with my original graph here of f of x equals x squared, our square function. And this time, I'm going to graph 2x squared. Now notice I'm putting the 2 inside with x instead of on the outside like we did with the verticals. Okay, so now let's find some points and graph this. If my x value is 0, which is this point right here, 2 times 0 would be 0, squared is still 0. If my x value is a 1, then I'd have 2 times 1 is 2, squared is 4. So that would be the point 1 comma 4. And then, of course, because of symmetry, we would have 1 on the other side. Because this square function is symmetrical, I can use that. What if my x value was 2? Well, 2 times 2 would be 4, squared would be 16. So I'd be way up here at the point 2 comma 16. And then likewise over here. So let's see. Ooh, that makes that graph very, very skinny. Interesting. Now, according to our definition, it said if the a value was bigger than 1, it compressed it horizontally. It's compressing or pushing in horizontally. Compressing horizontally would be pushing it in horizontally towards that y-axis. And that is exactly what happened here. It made our quadratic or our square function much, much skinnier. Okay, well, let's see what happens if we were to use something that was between 0 and 1. So let's say 1/2 x quantity squared. So again, let's use our points here. Let's 0 for an x value. Half of 0 would be 0. Squared is 0. And what about a 1? Well, half of 1 is 1. Squared is 1/4. So that's going to be very tiny in there. What about an x value of 2? 1/2 of 2 is 1. Squared is 1. Wow. What about an x value of 4? Half of 4 is 2. Squared would be 4. So that would be this point right out here. So can you see that that actually stretches that graph horizontally? Whenever I say, we're talking horizontally would be, like looking at the horizon. So if I'm stretching something horizontally, it's like I'm pulling it apart. This is exactly what's happening here to this graph.